And in today's episode, among other things, you'll see scientists are creating new data centers that will be powered by living human brain cells. One more, okay? It's a new Chinese humanoid robot that comes with realistic expressions and can smile and show emotions during its interactions. Chinese scientists are making progress with the brain-computer interface. Now, they are making it possible for wheelchairs to be controlled by thought. The American company is conducting a test flight with a prototype of a supersonic drone. And all of this will happen before the Mach speed tests. Let's understand all of this, my friends. And also some other technologies. Hello, impressed viewers. I am Realidade Impressionante, and you are watching Realidade Impressionante. One of the biggest limitations of electric cars has always been the same, okay? Where to charge them. But that could be about to change. KTL, one of the largest battery manufacturers in the world, has introduced a new robot that is autonomous and capable of bringing energy directly to the car. No physical station, no specific parking spot, no complex infrastructure. You just need to park your car and call the charger through the apps. The robot navigates by itself to the vehicle and connects automatically. Then it starts charging. In practice, any parking spot can now become a charging point. And this solves one of the biggest bottlenecks in electric mobility. Because in older or denser cities, installing fixed chargers is expensive, slow, and often unfeasible. Now, instead of bringing the car to the power source, the energy goes to the car. The system works like a mobile power bank. The robot has a 100 kilowatt battery and offers fast charging of up to 120 kilowatts. And these are levels comparable to charging stations, and all with autonomous navigation. It uses sensors like LiDAR, radar, and 3D vision to move around the environment, find the vehicle, and make the connection without human intervention. Real-world tests are already happening in China, including in residential areas, where hundreds of electric vehicles compete for just a few charging options. And the results show a direct gain in efficiency. A car with a low battery can reach a usable level in less than an hour. That's without waiting in line or having to move around. And without using fixed infrastructure. And this reveals an important change. Until now, the dominant model has always been based on stations. But this kind of solution points to a different scenario: on-demand infrastructure. Instead of building more fixed charging points, the system adapts to the user. KTL already has dozens of units in operation in China and plans to expand this technology to other markets in the coming years. And this robot is just part of a much bigger movement. The company is also integrating artificial intelligence, industrial processes, and automated services, showing that it's not just developing batteries, but an entire ecosystem around them. And this idea of bringing technology to the consumer instead of making them go to it isn't just happening with energy, okay? In some cities, it's already arriving in a much more viable and maybe much more controversial way. Let's take a look. For a long time, the promise of automation was pretty simple: to replace human labor. But now what's happening? It's a bit more complex. In the United States, especially in California, a new role has started to emerge: robot caretakers. Yes, people, human beings, being paid to accompany, maintain, and even, in quotes, rescue the delivery robots as they move around the city. These machines, used by delivery companies, are already operating on the streets, carrying orders, navigating sidewalks, and interacting with the urban environment. But in practice, they still don't work on their own. When a robot gets stuck, falls, encounters an obstacle, or simply can't complete a delivery, someone needs to intervene. And that's where these workers come in, the so-called robot babysitters. They used to be the delivery people, and after being replaced by robots, they got this new job. Among their tasks are collecting the robots, recharging the batteries, doing maintenance, updating the system, and often they still physically help with deliveries. In other words, the robot still depends on humans to function. And this creates a curious situation. Instead of independent drivers or couriers, fleet operators are emerging, hired by the hour, responsible for keeping these machines running continuously. And the numbers really show this transition. These workers earn between $21 and $23 per hour, which can actually be more than some couriers make. But it's still below what's needed for a comfortable standard of living in regions like California, for example. And this raises an important question. Are these robots creating new opportunities or just replacing one type of job with another, more controlled and less flexible one? Because unlike delivery apps, where the human worker can turn it on and off whenever they want, these operators now follow fixed shifts, taking care of machines that theoretically were created to replace them. And the impact of this is still not entirely clear. Delivery automation is still in its early stages, and factors like regulation and public acceptance can influence its expansion. But one thing is already quite clear. Technology is not just eliminating jobs, it is redesigning the human role within these systems. And maybe that's the most relevant change, because the future of work may not be just about humans or about machines, but about humans working to keep the machines running. And that completely changes the question, my friends. It's no longer just, are robots going to take our jobs, but rather, what kind of work will be left for us humans when these robots finally arrive? Let's shift topics but stay on technology. This time in the skies, stay focused. A startup called Humanoid flew its newest prototype, an experimental aircraft called Quarter-Horse Mk 2.1. It's a plane, or more precisely, an unmanned drone, about the size of an F-16 fighter jet. But what really draws attention isn't the size, it's the purpose. And this aircraft is part of a program that tries to solve one of the biggest challenges in modern engineering: flying at extreme speeds, close to and eventually beyond the hypersonic barrier. What's most interesting is how all of this is being done. Traditionally, developing a high-speed aircraft takes several decades, but Humanoid is taking a completely different approach. Instead of betting everything on a single project, they're building successive versions, each one testing a specific part of the problem. First, ground tests, then low-speed behavior, and now actual flight. The Quarter-Horse Mk 2.1 represents exactly this breakthrough. It's 3 times bigger and 4 times heavier than the previous prototype, and it was designed to gradually and controllably push the limits of performance. The maiden flight took place this March at subsonic speed, but that's intentional. Before speeding up, the engineers need to validate every critical detail: aerodynamics, flight control, and engine integration. That's because as the speed increases, the behavior of the air around the aircraft changes completely. Entering the supersonic regime isn't just about going faster. It's about entering a physical environment that's very different. That's why the design uses a delta wing optimized for high speed and a variable air intake system. This system adjusts the airflow as the plane accelerates. And all of this points to a much bigger goal. Quarter-Horse isn't their final destination. It's just another step. The real goal is the future aircraft called Dark Horse, a reusable hypersonic vehicle designed for strategic and defense missions. This will be a machine capable of operating at multiple speed ranges, using a combined cycle engine, something extremely complex that needs to work from low speeds all the way up to hypersonic regimes. And this search for more efficient, lighter, and smarter machines is happening not only in the air, it is also completely transforming the way robots are already moving here on the ground. It's a fact that until a few years ago when we saw Atlas walking, it was already pretty impressive. Then we saw videos of it jumping, running, and even doing parkour. The public started to get used to all of that, and today that's simply not enough anymore. Researchers from CAESH developed a humanoid robot called V0.7, a 75-kilogram machine that wasn't created just to impress, but to work in the real world. At first glance, it might even look like just another robot, just another ordinary one we've seen around. But this one was designed with a completely different approach. Instead of relying on ready-made industrial parts, the engineers developed almost everything from scratch: motors, controllers, transmission systems, everything optimized for a single goal: balancing power, precision, and real-time control. And this is where one of the greatest innovations comes in. The actuation system is known as a quasi-direct drive system. It allows for extremely fast and sensitive responses, something essential to keep the robot balanced while moving. In addition, it uses an advanced type of gear that can generate high torque in a much smaller space. In practice, this means much more strength with more control and less weight. But what really sets the system apart is not just the hardware, it's how it learns. Instead of simply programming movements, the researchers used deep reinforcement learning, a type of artificial intelligence that learns through trial and error. But this time, with a crucial detail: the robot doesn't learn on its own, it learns by observing us human beings. Motion capture data was used as a basis to teach the natural patterns of human movements. And the result? Much more fluid movements, more natural, less robotic, and still completely controlled. Another classic challenge in robotics was also solved here: the difference between simulation and the real world. Many robots work perfectly on computers, but fail when they face our physical world. To avoid this, the engineers limited learning based on the real capabilities of the motors. In other words, the robot only learns what it can actually perform. And perhaps most impressively of all, it can move even without vision, using only internal sensors to understand its position.
Então, equilíbrio e movimento.
It's as if they have a kind of quote-unquote body awareness. This means that these robots are no longer just programmed machines. They are now beginning to become systems capable of learning, adapting, and acting with real physical autonomy. And this is not just an isolated project. It's part of a much bigger plan from South Korea, which intends to bring humanoid robots to mass production in the coming years. But there's a pretty ironic detail in all of this. Until now, the biggest challenge was making robots move like us, like human beings. Now the challenge has changed. They can already do that. The next step is to look exactly like us, human beings. I'm a human, okay? Stop with those silly jokes about me being a robot. In the last few months, we've seen videos coming from China that started to go viral, showing humanoid robots with extremely realistic faces. Some blink naturally. They move their eyes with a lot of precision. They react to the environment as if they were conscious, but they're not. A recent example came from Headform, a company you've seen in several videos on this channel for a while. These are models capable of expressing facial microexpressions that are almost imperceptible to some of us. These are the same expressions that we use in our daily lives without even noticing. And this completely changes the game, my friends. Because until now, robots could be efficient, but they weren't socially accepted. They just worked, but they didn't connect. And this could be the real bottleneck of humanoid robotics: acceptance by us humans. The robot may even perform tasks quite perfectly, but without expression, without reaction, without presence, it remains just a machine. Now that seems to be changing. These new systems use synthetic skin, extremely precise micro-actuators, and artificial intelligence that is capable of interpreting and responding to visual, auditory, and also social stimuli. In other words, the robot doesn't just perform an action. Now it reacts, observes, responds, and also interacts with all of this. And when that happens, my friends, perception changes completely. Because we're no longer looking at a machine. We're looking at something that resembles and behaves like one of us. And this has always made us wonder, to what extent does a robot need to look like us to be accepted in society? Some experts argue that this is really essential, especially in areas like customer service, healthcare, education, and social interaction. Environments where it's not enough just to function, you need to communicate. But there's another side. The more a robot looks like a human, the greater the discomfort. Our discomfort, of course. The so-called uncanny valley, that point where something is almost human but not quite enough, can cause rejection instead of acceptance. This creates a paradox. Robots need to look human, but they can't look too human. Still, the industry seems to have already made a decision. The future of humanoid robots will not be defined only by strength, speed, or precision, but by the ability to look at us humans while appearing to be something alive. And if this trend continues, the most important component of a robot may stop being its body and become its face. Because in the end, my friends, it's not what the machine does that defines the intention behind everything. It's what we feel when we look at these machines. Because maybe true integration isn't in the body, but in the mind, in our minds. Focus on this next segment here. It's really interesting. You'll understand what I'm talking about. Yeah, I don't know when it started, but the idea of controlling machines just with thought has been on a lot of people's minds for a while now. And you should know that this is already happening, okay? Robots are already being controlled in real time by the minds of human beings. Researchers at Zhejiang University in China are developing systems capable of translating brain signals directly into commands for computers and physical devices. No touch, no voice, without moving a single muscle, no movement at all. It's just neural activity being converted into action. The technology behind this is known as brain-computer interface, and it was popularized here in the West by Elon Musk, the owner of Neuralink. But unlike Neuralink, in this case, it works in a non-invasive way. Instead of implants, the researchers used wearable devices like EEG headbands, which pick up the brain's electrical signals. These signals are then interpreted by artificial intelligence algorithms that identify the patterns associated with specific intentions. And the results are already quite concrete. During a demonstration, a user was able to control a wheelchair using only mental commands, moving it forward and making turns without any physical interaction. But that's just one part of the system. The same devices can also monitor mental states in real time, such as attention levels, for example. In one of the tests, the technology instantly detected when the user lost focus, showing that it's not just about controlling machines, but also about continuous interpretation of our minds. And this opens up a huge field of possibilities. Despite the dangers, there are also good things, especially in the health field. Patients with physical limitations can regain autonomy, control devices, move around, or even interact with the environment without relying on their bodies. The mind is no longer just the source of thoughts. It's started to become a direct channel of control. I just can't tell you whether we will be the ones in control, or if the machines will control us, or if we will be controlled. In short, I can't tell you any of that, if they aren't already controlling us through the algorithms that have influenced us in every aspect of our lives. But putting my paranoia aside here, let's see that it's not just about connecting the brain to machines, but about starting to use it. The brain itself as a... Now things are getting weird, huh? Of course you've heard of hardware, right? But what if the future isn't made of silicon, but of neurons? A startup called Quirkall Labs introduced a system they call Witware, a biological computer made with living human brain cells. The system, called CL1, uses about 200,000 neurons grown in a lab. These are fully connected to a chip that sends and receives electrical signals. In practice, it works like this. It stimulates these neurons and interprets their response as processing, input, and output, but using living tissue. And this isn't just another curious demonstration. It's a completely different approach to computing, because while traditional computers follow rigid instructions, neurons learn, adapt, respond to stimuli, and change their behavior over time. In other words, this type of system doesn't just execute code, it evolves with experience. And that's exactly why the company is taking the next step, creating biological data centers. Instead of racks full of GPUs, facilities with hundreds and, in the future, thousands of these units will be based on human cells. Each unit consumes much less energy than a simple calculator. And if this is scalable, the impact could be huge. But there are still many questions. We're talking about human neurons. They are being used as part of a computational system. And this raises questions that go beyond technology. Why? For the first time in history, the line between biology and machine is really starting to literally disappear. And if this evolves, the future of artificial intelligence may not only be in the algorithms, but in the very living structure that supports it. This episode was crazy, wasn't it? If you enjoyed it, leave a like and make sure you're subscribed. Click one of the 2 suggestions and I'll see you next time. Thanks for staying with me. Just click and see you soon. Thanks and bye.